Hello class, I'm working out of your Algebra 2 book 6.6 Factoring Polynomials. We're doing number 22 as an actual example. In number 22, you are given p of x equals ax cubed minus 12x squared plus 6x minus 1. Remember, the constant term is the p term, and the coefficient to the highest degree term is the q term. So in evaluating our factors for p and q, we have p equals plus or minus 1. We have q equals all the factors of 8 plus or minus 1 plus or minus 8 plus or minus 2 plus or minus 4. Now remember, we make a fraction from p and q to find our possible rational zeros. So our possible rational zeros in this set are p over q equals plus or minus 1 as 1 over 1, plus or minus 1/2, plus or minus 1/4, and plus or minus 1/8. We need to think about what could possibly be all our zeros in our polynomial. There are only 3 because the highest degree of the polynomial is 3. That means there are 3 zeros possible out of this grouping of possible rational zeros. We start testing maybe at 1 and on until we find a 0. So to do that, we plug 1 in for x to start. Our original polynomial was 8x cubed, so x will now be 1 cubed minus 12x squared. X will be 1 squared plus 6x. X will be 1 minus 1. Let's see what our answer is to this substitution. So that will give us 8 minus 12 plus 6 minus 1. Solving for this, we get p of x being 1 is equal to 1. That's not a 0. So that is not a solution to this polynomial. Let's try the 1/2. And we're going to try positive 1/2. So we plug it in for x to remind us. And that's going to equal 8 times 1/2 cubed minus 12 times 1/2 squared plus 6 times 1/2 minus 1. Let's solve. 1/2 cubed would be 1 over 8 minus 12 times 1/2 squared would be 1 over 4 plus 6 over 2 is 3 minus 1. Solving and simplifying further, we have 8 over 8 is 1 minus 12 over 4 is 3 plus 3 minus 1. That equals 0. We found a 0 for our polynomial at positive 1/2. Now we can depress the original polynomial and factor to find the remaining zeros. Remember, our remainder theorem is x minus a. And since our first zero we tested for is 1/2, that is going to be a possible zero at x minus 1/2. We'll need that in a little while. But remember, that's part of the formula. So we're actually working with the positive 1/2 we found as an actual zero. We're going to take 8x cubed minus 12x squared plus 6x minus 1. Make that cubed a little bit better. It caught at the top. There it is. Just catching at the top. Okay, that's supposed to be 8x cubed. We pull our coefficients for synthetic division. And to do that, we're going to have 8, negative 12, 6, negative 1. Remember to check that your polynomial is in descending order. And if there is not a coefficient for a term in descending order, put the value of 0 in there, in that place value. Okay, we're going to move our 8 down. We have 1/2 times 8. That's 4. Set it here. Negative 12 plus 4 is negative 8. Now we have 1/2 times negative 8. That's negative 4. Set it here. 6 minus 4 is 2. We have 1/2 times 2. That's 2 over 2 is 1. Set it here. Negative 1 plus 1 is a 0. Our new polynomial from synthetic division becomes 1 less degree than we started with for the first term. So we're going to have 8x squared minus 8x plus 2. So in working with x minus a, which is a positive 1/2, it looks negative when we put it in this format, but it's the x minus a remainder theorem that we're plugging it into. At positive 1/2, our remainder is 0, so it is a 0. That's why we're using this. And multiplying it by the 8x squared minus 8x plus 2 in the depressed polynomial, we can factor out a 2. So to do that, we're going to say 8 divided by 2 is 4x squared minus 8 divided by 2 is 4x plus 1. Okay, so what we can see now is the square of a difference emerging. And if that's true, then we can take the 2 we factored out and multiply it by our first parenthesis set as well. And we're going to have this emerge in our factoring. 2x minus 1. Multiplying these two together. And then the square of a difference would be 2x minus 1 squared for this part of the polynomial. We see that these are the same, so we can combine them. And factoring all the way, we're going to get 2x minus 1 to the 3rd power. I hope this helps, and I will see you soon.